They called it a motionless desert, a silent realm of eternal darkness. Yet here in the depths of the Northeast Atlantic, we have found a world teeming with surprise and transformation. That might sound like the breathless tagline of a sci-fi blockbuster, but it is precisely what pioneering researchers have discovered beneath the waves of our planet's vast unexplored frontier. Today, we plunge into the heart of the Porcupine Abyssal Plain Sustained Observatory, a unique oceanic testbed that has shattered assumptions and challenged scientists for nearly 4 decades. What exactly is going on in this deep ocean stronghold? And how could its hidden life forms and ever-shifting environment reshape our understanding of Earth's future? In this episode, we will untangle the riveting story behind one of the most remarkable scientific undertakings on our planet. We will encounter bold exploration, advanced technology, and a dedicated team of oceanographers who set out on a 25-day voyage from Southampton to the Porcupine Abyssal Plain Sustained Observatory, often called PAP-SO, to celebrate 4 decades of continuous research. We will uncover the daring leaps that revolutionized our view of the deep sea, from the uncrewed surface vessel roving over stormy waters to the underwater gliders coursing through inky darkness. Together, we will see how these robotic explorers help us interpret longer-term shifts in ocean health, measure the power of our planet's carbon sink, and track the startling changes at the bottom of the sea. But first, let us set the stage. The Porcupine Abyssal Plain Sustained Observatory lies about 800 kilometers southwest of Land's End and at the edge of the Northeast Atlantic. Established in 1985, this site descends to a punishing depth of roughly 4,850 meters, far deeper than the mountains that dominate our landscape. For many years, conventional wisdom suggested that this realm of crushing pressure and cold temperatures was unchanging, a place where the environment remained forever locked in quiet stasis. It was assumed that little could challenge the stability of a realm so remote from the dynamic churn of surface winds, currents, and daily weather patterns. Yet those early expeditions soon discovered that far below the crashing waves and howling gales, seasonal cycles and environmental fluctuations had an astonishing presence. The abyssal plain was alive, in more ways than we ever dreamed. Here's the question that researchers found themselves asking back then. If the deep sea was so remote and stable, how could subtle changes in surface conditions and global climate cycles ripple all the way down to the dark ocean floor? The answer would come in waves of data, meticulously collected over years, then decades. Early studies at PAP-SO revealed that plankton blooms high in the water column could generate pulses of organic matter that drifted to the bottom. This material, in turn, influenced the life of creatures dwelling on or near the seafloor. Suddenly, scientists recognized that what happened at the sunlit surface was intimately linked to events nearly 5,000 meters below. That revelation cracked open an entirely new perspective on the sea. Now, in the year 2023, a new expedition sets out to mark the 40-year milestone of PAP-SO research. Led by the United Kingdom's National Oceanography Centre, the scientist team boards the Royal Research Ship James Cook, an imposing vessel purpose-built for advanced explorations. On this latest endeavor, known as Expedition JC-278, the researchers combine time-honored scientific methods with a suite of futuristic autonomous technologies. Gliders outfitted with miniaturized sensors dive silently through columns of water, collecting temperature, salinity, and carbon data. Overhead, an uncrewed surface vessel scuds across the waves, relaying signals and measurements in near real time. All these pieces fit together like an elaborate puzzle, revealing how the ocean's role as a carbon sink might evolve, and whether it is as stable and unchanging as we used to think. Since its inception, PAP-SO has served as a window into the little-known realm of abyssal plains, which stretch across much of Earth's seafloor at depths between 4,000 and 6,000 meters. In the early days, the findings were almost shocking in their implications. Researchers had expected monotony and discovered dynamic seasonal shifts, an insight that struck them like a thunderbolt. Over the years, more data poured in. Instruments measured the chemical composition of the water, tracked the migratory patterns of tiny organisms, and even captured the daily rhythms of scuttling sea-bottom creatures. These observations gave rise to an unsettling realization. Certain changes in surface climate patterns might have a powerful ripple effect on the deep ocean. If global warming alters the vigor or timing of plankton blooms, for instance, how might that cascade through the food chain? Could warming seas or acidification hamper the deep ocean's capacity to store carbon? That leads us to the crucial point of our story. The deep ocean is an unsung hero of global climate regulation. It naturally absorbs enormous amounts of carbon dioxide, helping to moderate greenhouse gas levels in the atmosphere. Yet this delicate balancing act depends on conditions we are only beginning to understand. If the system is pushed too far, through temperature shifts, acidification, pollution, or other human-driven changes, we could see global impacts that reach far beyond the ocean's edge. That is why critical sites like PAP-SO are more than just scientific curiosities. They are vital outposts that shed light on our planet's future. By now, you might be wondering, what shocking revelations could await in such a seemingly untouched region? Well, if you are as fascinated by Earth's mysterious frontiers as I am, go ahead and let me know you are on board by giving this exploration your support. Perhaps a quick sign of encouragement is all it takes for us to keep diving deeper. The full extent of PAP-SO's significance is only coming into focus now, because the expedition has recently deployed new instruments that promise to push scientific boundaries even further. One of the highlights of this latest journey is the testing of technologies developed under the Horizon Europe-funded George project. Miniaturized sensors and samplers, imagine devices once the size of a kitchen appliance, now shrunk down to something more akin to a pencil case, are mounted on both underwater gliders and that daring uncrewed surface vessel. Dr. Socrates Loukaides, one of the lead scientists from the National Oceanography Center, describes the potential breakthroughs these devices might yield. Because PAP-SO has an unbroken record of data spanning decades, new measurements can be compared against a massive archive of historical data. In other words, if these advanced sensors detect subtle anomalies, we will know they are real and not merely random fluctuations. Of course, none of this is happening in a vacuum. The expedition also involves the placement of hydrophones that will capture the soundscape of the deep ocean for an entire year. Imagine listening in on a hidden orchestra of groaning tectonic plates, mysterious biological clicks and whistles, and the far-off vibrations of ships passing overhead. Studying the acoustics of the deep sea can illuminate many aspects of underwater life, from marine mammal migrations to potential noise pollution from human activities. Meanwhile, the time-lapse camera known as BathySnap, which has spent the past year filming seafloor life in slow, deliberate frames, is due for retrieval. This is no ordinary camera roll. It is a record of day-to-day changes in the benthic community that was once assumed to be nearly static. Such footage can reveal how creatures respond to the trickle of organic matter, how they interact with each other, and how frequent certain cyclical patterns really are. Given all these fascinating details, it might be easy to overlook the sense of adventure that permeates an expedition like this. The ocean is never entirely predictable. Storms can roll in, swallowing the horizon with heaving waves that threaten the delicate dance between scientists, advanced sensors, and expensive infrastructure. Equipment can malfunction under the mind-boggling pressures at depth. And though technology has advanced dramatically in the last 4 decades, the sea still guards many of its secrets. Tucked within that silent gloom lies the thrill of discovery, new species, unexpected geological formations, surprising chemical signals that point to novel phenomena. The story of PAP-SO is, in many ways, the story of humanity's drive to understand our planet's most elusive boundaries. This impetus to keep exploring leads to a bigger question. How does the knowledge gleaned from a single location in the Atlantic relate to the rest of the world's oceans? After all, the planet's seas stretch far beyond 800 kilometers southwest of Land's End. But PAP-SO's long-term data series, combined with parallel research at other sites, offers vital comparisons. If scientists notice that certain patterns at PAP-SO, such as shifts in carbon export or changes in biodiversity, are echoed at other deep-sea observatories, we begin to piece together the puzzle of how the global ocean evolves in response to climate forces. Conversely, if PAP-SO shows anomalies that are not mirrored elsewhere, that is equally important. It might indicate local environmental pressures or unique ecosystem traits. The result is a mosaic of knowledge, each point of data contributing to a grander portrait of Earth's watery domain. One of the more urgent aspects of this work concerns climate mitigation strategies. Policymakers and environmental stakeholders often talk about nature-based solutions or carbon offsets. The ocean, particularly its deep abyssal plains, can sequester carbon for centuries or even millennia. If changes in ocean circulation, temperature, or biology disrupt that sync, we could face a startling acceleration of greenhouse impacts. Researchers at PAP-SO are therefore attuned to how the deep ocean's chemistry and biology fluctuate over the long haul. They measure tiny changes in the pH levels and dissolved oxygen, track how nutrients move from surface waters to the benthos, and monitor potential shifts in species composition that might indicate stress or resilience. This comprehensive approach helps us prepare for and possibly mitigate future climate scenarios. As we continue, we must recognize the unique challenges lurking in the deep. Funding for extended ocean research can be precarious, subject to changing political winds and shifting budget priorities. Launching an expedition like this requires not just a dedicated crew, but advanced vessels, specialized remote-operated vehicles, robotic gliders, and a robust supply chain of scientific instruments. And then there are the physical and mental strains on the team during a voyage lasting weeks or even months. Scientists might need to wrestle with storms, malfunctioning equipment, or the emotional toll of isolation. Yet the urgency to gather these observations is greater than ever because the ocean, once seen as an inexhaustible resource, is beginning to show signs of stress. This is precisely where the Porcupine Abyssal Plain Sustained Observatory flexes its importance. Unlike brief research cruises, PAP-SO provides a living library of ocean health extending through 40 consecutive years, capturing data in calm times and tumultuous eras alike. That means scientists can correlate changes in ocean properties with major climate events, from El Niño anomalies to shifts in the North Atlantic Oscillation. They can also track how biodiversity at the seafloor responds to the complexity of human-induced changes. The operation takes a staggering level of dedication, but it returns insights that a short-term study might never glimpse. In fact, the team revealed that what happens on the surface, a plankton bloom, a shift in wind patterns, a surge of ocean eddies, can heavily influence conditions at the seafloor, though it may take weeks or months for these pulses to filter down. This layering of time and space is what makes the deep ocean so captivating. It is at once a record of the past and a stage for future transformation. So, if this hidden frontier of knowledge is stirring your curiosity, and you want to see it unfold even further, let us hear that excitement. Consider taking a moment to follow this story closely, so you do not miss the unfolding chapters in our exploration of Earth's final frontiers. Circling back to the new frontiers of technology, the gliders roam in near silence, scanning for temperature gradients, oxygen levels, or the presence of carbon compounds. This real-time capability allows them to adapt their path, diving deeper when they detect something unusual, or rising close to the surface when they need to recharge their solar systems or transmit data. Meanwhile, the uncrewed surface vessel might appear comparatively simple, essentially a sleek boat bristling with sensors, but it is also a game changer. It can stay at sea for extended periods, powered by solar panels or wave action, collecting atmospheric and surface ocean data while sparing scientists from potentially dangerous conditions. This synergy between gliders, surface vessels, and more traditional ship-based sampling is revolutionizing how we study the ocean, pushing the boundaries of observation like never before. During each annual trip to PAP-SO, this recent one being the 41st in total, scientists must carefully retrieve instruments that have lain below for months. If not an entire year, then replace them with fresh gear. Consider the BATHY-SNAP camera, which might have quietly recorded thousands of snapshots of deep-sea life. In that time-lapse, brittle stars may have ventured across the sediment, colorful sea cucumbers might have clustered to feed on decaying plankton, or tiny crustaceans may have formed dynamic swarms. Gaining a full year's perspective on these communal interactions is invaluable. By pulling up the camera now, researchers will see how seasonal pulses of food or temperature changes have altered the ebb and flow of deep-sea living communities. As if that were not extraordinary enough, the new camera system tested on this voyage promises to photograph microscopic organisms from seawater samples every 30 minutes, with future plans to interpret those images through artificial intelligence in real time. Think about that for a moment. What once required collecting water, returning it to a lab, and examining it under a microscope could soon happen autonomously in the middle of the Atlantic. This means a richer, more constant flow of data that can capture ephemeral events like the sudden bloom of certain phytoplankton or the unusual presence of microorganisms that might herald changes in ocean chemistry. In short, We are on the cusp of real-time oceanic intelligence, a concept that just a few decades ago would have seemed straight out of futuristic fiction. Naturally, the significance of this research extends far beyond the scientific community. Humanity relies on healthy oceans for oxygen production, fishing, climate regulation, and more intangible benefits like wonder, exploration, and discovery. When the ocean suffers, we all feel the repercussions, whether in the form of coastal flooding, changing fish populations, or broader climate ramifications. Delving into the PAP-SO data helps us refine climate models, shape global negotiations on emission reductions, and inform marine conservation strategies. It also unveils the resilience and vulnerability of life at the greatest depths, life that is out of sight but far from out of mind. Along the way, there is much still to learn. How will a warming ocean influence the metabolic rates of deep-sea creatures? Could subtle chemical signals lead to new breakthroughs in biotechnology or medical research? Is there an even deeper network of microbial processes that help lock away carbon over geological timescales? Each year, the Porcupine Abyssal Plain Sustained Observatory yields new lines of inquiry, new reasons to keep searching, and new puzzles that challenge existing assumptions. When Dr. Andrew Gates, the principal scientist at the National Oceanography Center leading the expedition, highlights the seasonal changes on the abyssal seafloor, he is pointing to a fundamental lesson: that what we see on the surface is not an isolated phenomenon. Climate, biology, chemistry, these weave together into a tapestry of processes that cycle from the top of the ocean all the way down into its darkest reaches. Knowing that the deep sea is not static, but rather shaped by these ever-shifting patterns, we begin to see the broader do-or-die significance of ongoing research. With the help of long-enduring datasets and cutting-edge technology, we can spot worrying trends early, plan adaptive measures, and protect ecosystems that we barely comprehend. It is an extraordinary intersection of science, engineering, adventure, and hope. The presence of the Atlantis program, supported by the Natural Environment Research Council in the United Kingdom, ensures that this crucial research continues to thrive. Yet we must reflect on how precarious it all can be. Without sustained support, these monitoring efforts could falter just when the data is most urgently needed. Continuity is everything in long-term environmental tracking. The disruption of a year or two can cause gaps in the record that hamper our ability to interpret trends successfully. That is one reason campaigns like this expedition represent far more than a single data-gathering foray. They symbolize a global commitment to watch, learn, and steward the oceans responsibly. In closing, let us circle back to the heart of it all. The Porcupine Abyssal Plain Sustained Observatory started as a small pocket of scientific curiosity in 1985. 4 decades on, it has evolved into one of the crown jewels of deep ocean exploration, confirming that the darkest stretches of the sea are not silent graveyards, but living, pulsating domains brimming with crucial insights. With each wave of new technology, miniaturized sensors, self-piloting gliders, advanced cameras, researchers peel back another layer of the ocean's mysteries. And each discovery has the power to guide policy, spark innovations, and inspire wonder in a world that can sometimes feel short on all three. The deep sea may remain out of reach for most of us physically, but intellectually, it has never been closer. Every snatch of data from PAP-SO is an invitation to see the Earth differently, to recognize that ecosystems thousands of meters down might hold the key to climate resilience at the surface. Whether it is the swirl of planktonic blooms or the hushed spectacle of creatures on the seafloor, this tapestry unfolds in a vital dance with global processes, and it is a dance that concerns every one of us. So, if you are excited to continue this journey, consider staying connected. There is no better way to keep the momentum going, ensuring our oceans remain a shared frontier of awe and learning, one that all who are curious can help defend. In the end, the real surprise is not that the deep ocean changes, but that it has so much more to teach us, again and again, no matter how far we think we have progressed. The Porcupine Abyssal Plain Sustained Observatory has showcased how the deep sea, with its seemingly eternal darkness and crushing pressures, can respond to fluctuations in climate, surface productivity, and even the gentle hum of passing storms. As we push deeper into this new era of exploration, maritime technology, and environmental vigilance, we cannot help but wonder, what revelations will tomorrow's sensors capture, And will we be ready to interpret them in time to protect the planet we call home?